Okay, 1.7. Now we're moving on from lines to graphing linear inequalities. So remember, when graphing an inequality of one variable, we need only one dimension. So we use one number line. For example, m is greater than 7. We put a 7. It's an open dot. Here, we divide by 2. We get p is less than or equal to negative 5. In this case, negative 5. We use a closed dot, but it's less than. So since there was one letter, we only needed one line. But now, when we graph an inequality in two variables, we need two number lines. The xy coordinate plane to represent all the ordered pairs xy that are in the solutions to the inequality. First, practice determining whether a given ordered pair is a solution to an inequality. So what we do is we just take, remember our x and our y, and we're going to plug it in. So 0 is going to go here, and 1 is going to go here. And we test it. Does it make a true statement? So 2 times 0 plus 3 times 1 greater than 5. Well, 2 times 0 is 0, plus 3 times 1, which is 3, greater than 5. 3 greater than 5? No. False statement. So 0, 1 is not a solution. It is not in the area that makes that a true statement. How about this one? Negative 2, negative 9. I'll come over here. So 4 times negative 2 minus 2 times negative 9 less than or equal to 8. Well, 4 times negative 2 is negative 8 minus 2 times negative 9 is negative 18 less than or equal to 8. We add 18 minus 8 is 10 less than or equal to 8. Also not a true statement. So neither of those are a solution to that inequality. So remember, we're going to use a solid line for less than or equal, greater than equal. Remember, earlier we used brackets and dots. These all go together. And we're going to use a dotted line. This is where it's really important to use pencil. For less than or equal, greater than equal. And remember, before we used parentheses and an open dot. Those go together. We're going to test an ordered pair that is not on the line. If the point is solution, then shade the side that contains the point. If not, we shade the other side. A solution to an inequality is found in the shaded region. So, we're going to graph each inequality and fill in the requested information. So, y is less than or equal to negative 2. Well, I'm going to look for the line negative 2. Since it has a line here, I'm going to use a solid line. So here's the line y equals negative 2. And I use a solid line because it's less than or equal. Now, at this point, when it's a horizontal line, less than is clearly going to be shaded down here. But you can still pick a point anywhere that's not on that line to test. A lot of people like to pick 0, 0 because it's very easy to plug in. Well, here's my x, here's my y. I only have a y to plug in. So I plug it in and get 0 is less than or equal to negative 2. Well, I'm testing this point right here. That is a false statement. So since it's false, I shade the other side of the line. Let's say I shaded something like 0, negative 11, which would be down here, off the chart a little bit. Well, I'm going to plug that in. Negative 11, less than or equal to negative 2. That is a true statement, which means this point is in the region, and therefore I shade that side of the line. y is greater than 2x. Okay? This is, if you're doing mx plus b, you could say it goes through 0 right here, and the slope is 2 over 1, up 2, right 1, up 2, right 1, and so forth. I can also go down 2, left 1, and so forth. Another way to do this would have been the xy intercept, where you plug in a 0 for y and solve for x, plug in a 0 for x and solve for y. You could have done that. Now, since there's no line, I need to use a dotted line. Here's where using a pen is bad, because if you accidentally draw a line, you can't do anything. But with a pencil, if you accidentally draw a line, you can take your handy dandy eraser and cut yourself out, erase part of it, or just erase the whole thing and start over and make it into a dotted line. Okay? So there you go. Now we need to test. So again, a lot of people like to test 0, 0, but we can't use that because it's on the dotted line. So just pick any other point. Like let's say 1, 2, 3, 4, 1. How about that one right there? Let's just test 4, 1. I'm testing 4, 1. And let's see if it's in the region or not. So 4, 1, I plug it in. 1 is my y, greater than 2 times 4. 1 is greater than 8. Is that a true statement? No. So therefore, I don't shade this side where the dot is. I'm going to shade this side. Now, when asked for a solution, I skipped over, I'm sorry. Any number that works. Any number. So down here, we tested 0, negative 11. That's a solution. How about down here? That's in the region. That's 10, negative 9. That's a solution. So basically, you pick any number in the shaded region. And actually, you could even pick a number on the line because since it's a solid line here, that is in the answer. So this one, 0, negative 2, would work. Over here, we have to choose anything not on the line, but in the shaded region. So, for example, right here, 0, 2. Obviously, 4, 1 is not a solution. Negative 10, 1, 2, 3, out there. Negative 10, 3. Just basically anything that is in the shaded region. But when we have a dotted line, we cannot pick one on the line. So 0, 0 would not be a solution. And let's see why. Let's just see why. Y is greater than 2x. If I said 0 is greater than 2 times 0, I'm saying 0 is greater than itself, and it's not. But imagine if this was greater than or equal, that's why it is okay when there's a solid line. Okay, number 3, you can solve this for y. Okay, you can put in y equals mx plus b form. If that's what you like, go ahead and do it. You would, I'm going to move the 5y over to make it positive so I don't have to worry about flipping the sign. So I would get 5y is greater than or equal to, move the 10 over, 2x minus 10. Divide by 5, and I would get y is greater than or equal to 2/5 x minus 2. So that would be negative 2 for a y-intercept and a 2/5 slope. Up 2, right, 1, 2, 3, 4, 5. Up 2, 1, 2, 3, 4, 5. I go down 2, left 5, down 2, left 5. And it's a solid line since it's less than or equal. Sorry, greater than or equal. Now it's asking for the slope, so I kind of had to do this form. Slope is positive 2/5, and the intercept is negative 2. Now, I could, though, have also just done the x and y intercept. Plug in a 0 for x, find out y. And plug in a 0 for y, and found out x. If I would have done that, 0 for x will give me negative 5y equals 10, so negative 2, and that's the y-intercept we already had. If I plug in a 0 for y, that would give me 5, 0. Well, look, I do have that point. So you could have done that method and still gotten the line, and still even then have figured out the slope and the y-intercept. We already have the y-intercept right here, and I could count the slope. That way or that way. It makes no difference. Now, I need to figure out which side to shade. I'm going to pick 0, 0 because it is the easiest. So if I plug in 0, 0, it makes the x disappear, it makes the y disappear. I end up with a statement of 0 is less than or equal to 10. Is that a true statement? No, it's not a true statement. I don't know what I'm saying. Of course it's a true statement. My brain's not with me. Sorry. So 0 is definitely less than or equal to 10. And so therefore 0, 0 is a solution. I'm going to put that right here. So I'm going to shade everything up here. And I could tell anything up there could be a solution. You know, negative 5, 8 looks like a solution. Okay, this, again, I have no y-intercept written, but it's 0. My slope is 3 over 1. Or is it? No, it's not. My slope is 0, but look what we have here. A negative 1. We need to divide by negative 1, which is going to flip my symbol. So I'm going to end up with y is greater than negative 3 over 1x, and there's my 0 again. So y-intercept doesn't change, but slope does. So you have to be very careful to pay attention if there's a little negative there without a number showing, because it truly is the number negative 1. So now my slope, instead of going up and to the right, is going to go down and to the right. 1, 2, 3, 1. 1, 2, 3, 1. 1, 2, 3, 1. Or up, 1, 2, 3, left 1. 1, 2, 3, left 1. 1, 2, 3, left 1. And it's going to be a dotted line because it is the greater than symbol. I also cannot test 0, 0 because it goes through there. So I'm going to pick a nice easy number like 1, 1. So I'm going to plug it in. 1 is greater than negative 3 times 1. 1 is greater than negative 3. Is that a true statement? Yes. 1 is greater than any positive number. So I'm going to shade everything over here. And since that worked out, I can just put 1, 1 as my solution. I could also pick 5, 0 or 10, negative 3 or 7, 18 because it's going to be in that region. Okay, if you remember from algebra, this is the same thing as y. So mx plus b, here's my m, here's my b. Negative 1 for the intercept, 2/3 for the slope. Negative 1 is my y-intercept. I go up 2, 1, 2, right 3, 1, 2, 3. And I keep repeating that pattern. Up 2, right 3. I can also go down 2, left 3. It is also going to be a dotted line because it is less than. And I'm just going to pick 0, 0 because it's the easiest thing to do. 0 is less than negative 1. Because 0 makes this disappear, right? Is 0 less than negative 1? Of course it's not. 0 is greater than any negative number. So 0, 0 is not a solution, which means I have to shade down here. So I can pick any number in that region, like, 1, 2, 3, 4, 5, negative 2. That is in the solution area. Okay, again, I have a problem here because I have this negative y. So I need to divide everything by negative 1. So that's y, switch my symbol, positive 4x minus 3. So my y-intercept is negative 3, my slope is 4, or 4 over 1. So I go to negative 3, I go up 4, right 1. Or down 4, left 1. I'm going to use a solid line because it's less than or equal. Again, 0, 0 is nice and easy, so I'm going to plug in 0, less than or equal to 4 times 0 is 0, minus 3. Again, 0, 0 is not less than any negative number, so I'm going to shade over here. My solution, pick something over here. How about 9, 0? It works. You can pick anything you want. Okay, Ms. Roth took her grandchildren to a baseball game and wants to spend no more than $10 on snacks. An order of nachos costs $5 and a bag of popcorn costs $1.25. Write an inequality that describes the situation, then use the inequality to graph. So we define our variables. X is going to be nachos, Y is popcorn. Doesn't matter. It could be switched around. But then I have to put the money with the variable. So nachos is X, so that's 5X. 1.25 Y for the popcorn. And it's got to be less than or equal to, because it says no more than. So it could be 10, but no more. So that's why it's less than or equal. Okay? So I can do either method I want here. I'm going to do the 0 method. X and Y intercept. When I plug in a 0 for X, it makes this disappear. So I basically just need to then solve for Y by dividing by 1.25. When I do that, how many times does $1.25 go into 10? That's 8 times. Okay? I'm going to do it again, except this time I'm going to plug in a 0 for Y. So I get 5X, 125 times 0 is 0. Less than or equal to 10. Divide by 5 gives me 2. So I go to 0, 8. And I go to 2, 0. And it's going to be a solid line. Always use a straight edge so it can look as good as that. And then I pick a point. Again, I like 0, 0. It's easy mathematically. When I plug in 0, 0, I get 0 plus 0 less than or equal to 10. 0 is less than or equal to 10. That's a true statement. So therefore, I'm going to shade everything over here. Number 8. The absolute value inequality given is 1 mile for normal body temperature of an adult, where temperature is measured in degrees Fahrenheit. Solve the inequality and graph the solution. Okay? Well, it's by itself, so I do T minus 98.4 less than or equal to 0.6, and T minus 98.4 greater than or equal to negative 0.6. So I'm going to add 98.4 to both sides, which will give me 100. And I'm going to do it again. Uh, 98.4, that would be 97.8. Okay? So that means T has to be greater than 97.8 and less than 100. in that range. If I was putting as an interval notation, 97.8, 100 with brackets. And then where might we see something like this? As class rank goes up, ACT score gets higher. We're doing the shaded region above. Think about that. We'll talk about it in class.